Adding and subtracting rational expressions. This is just 5th grade practice on adding fractions. How do you add fractions? Can you add? You just add. Is that cool?
Oh man.
Can we
no.
do this? Just this? Leave it at this?
Hey, I can add. 2 plus 3 is 5. And 3 plus 4 is 7.
No. You have to make them both 12 first. And it has to be.
Okay.
Yeah.
Good. Don't we need a common denominator?
8.
So it becomes like
Oh wait, I thought you were. I just wrote that.
Well, I made 2 8. So
when you're adding fractions.
4 and then 2 times 4, which is 8.
Thank you, Dan. He did remind us we need a common denominator. How do you decide on a common denominator?
Just multiply both the denominators together is the easiest part.
You can't just do that. You can multiply the 2 denominators together. Or you can, it's called the smallest common multiple.
Oh, I can't.
What's the smallest number that both of those can divide into?
12.
Can they both divide into 12? Yeah. Why do we not just use 24? 6 times 4 is 24.
Because they both go into 12.
Because they both go into 12 instead. So you can just multiply these two and get the common denominator, or you can think about something smaller than 24 that might work. And Jake jammed right on to 12 here and said they both can divide into 12, so 12 is a better idea. So what's the plan? How do we get 12 out of this one? We have to multiply 4 times 3. So you multiply by 3 over 3. Multiplying by 1 doesn't change the value. It will change how it looks, but it won't change the value. So that will be 9 over 12. How do I get 12 on the bottom of this one? Multiply by 4 over 4, and you get 8 over 12. Now that you have a common denominator, you can add them. And we've already done this one. What's the common denominator? The best one is 12. You could use 24. That's okay. If you do use 24, then you'll have a bigger fraction that you have to cancel back down. But so what?
Some people prefer that.
Yeah. Some people prefer the big denominator and cancel it back down. Up to you.
Oh my goodness, get ready.
Okay. So, what do we do for a common denominator in messy things like this? Okay. Olivia was getting the common denominator in her head and seeing how to create the common denominator all in one step. So some of you can probably do that. What's a common denominator for just these two, 18 and 15? Boy.
3.
One plan is to find the multiples of 18 and stop when you get one that can be divided by 15. So take the big one. What's the next multiple of 18? 36. Does 15 go into 36? No. What's the next one after that? 54. No. What's the next one after that?
72.
72. Can 15 divide that? No. 90.
Yes.
Can 15 go into 90?
Yeah.
Yay. What you might do is what Dan said and just use 15 times 18. Use the big denominator and then cancel it back down later. So 90. 90 what? What's the common denominator? It needs all of this in it, and it needs all of this in it. in order to have all of this in it, how many y's does it need?
90x y2.
Right.
Where was the X?
So we've got this guy covered now, but it also needs to have all of this in there. What is missing? Do we have the y covered? But do we have the x covered yet? No. So there's our common denominator. It has all of that and all of that built in. What does this need?
But how do you know if that goes into x? Like,
Okay,
how do you know if the other denominator, like the other denominator doesn't have an x?
no, but we need to create that x in the bottom right now.
So we just add an x.
You multiply an x
Just,
because you need,
oh, okay.
yeah, okay, let me back up here. Well, I'm not going to back up here. The common denominator, when you if you needed a common denominator for this, the common denominator has to have this in it and this in it. The smallest thing you can think of that has all of that and all of that in it is it only needs that to have the A's covered. But what else does it need?
The B and C.
A B and a C. So is all of this, is A and C down in there? Yes. Is A and B both down in there? Yes. And then you'd have to say, well, how do I make this denominator have A, B, and C? It needs a B, doesn't it? And then it'll have A, B, and C. And what does this one need? A C. And then it will have A, B, and C. So this one would be B plus C over ABC and over ABC, so they will have a common denominator. That's what we're doing. So it needs an A, a B, and a C. Just like this one, it needs all of this. We've got 90 covering this. We've got the y squared covered. But it also needs all of this. The 90 covers this. It needs an x for that and a y. But we've already got more y's than we needed up there, so we're good. That y is already down there. Don't put another one. Now our job here is how do we create the common denominator for this? What times 8 makes 18 makes 90? 5. And we're trying to create this common denominator. Do we have the 90 covered now? What else does this denominator need to have in order to have the common denominator? It needs a y as well. Now will this have the common denominator? 90x y squared. 90x y squared. What does this one need for the common denominator? How do you get 15 to become 90? Times 8 is 40. No, 6. There's my 90. What else does it need for the common denominator? Okay, good. An x. So multiply by 6x there and 5y there. What does this numerator become? 42x squared and 5y squared. Was that too hard a problem to start with? Maybe a little bit. Okay?
Yeah.
Do this one.